All right, this example, and this is our last one, but this is an example of why I showed you how to convert from the half-life formula to the exponential form. So we want to use the form y equals, or f of x equals a times b to the x. We want to find a function for the decay of strontium 90, and we know the half-life is 28 years. Well, b now, you know that b is equal to 1/2 to the 1 over k. So let's go ahead and calculate what b is for strontium 90. So b is 1/2 to the 1 over 28. And make sure and put parentheses around that before you actually calculate it out. And when you do that, you're going to find that b is 0.9755. And again, we want to carry this out to 4 decimal places. Okay, so now I have a function y equals a times 0.9755 to the x, and I think that's maybe easier to use than half-life. Okay, so there's part 7, and then part 8 on your handout says use this new function to find how much strontium 90 is left after 50 years. So part 8 says we have time, or x, equals 50 years, and we want to figure out how much is left. So y equals, and again we could use 100% or we could use 1. Let's use the 1 and then convert it later. 0.9755 to the 50. And when you do that, you get 0.29, and when you convert that out, you get 29%. And I'm going to pull my calculator up here. I want to show you something. So what I have done is I have plotted in y sub 1, I have plotted the half-life formula for strontium. So we have 1 times, there's my 1/2, I just did it in decimal, to the power of x over 28. And then in y sub 2, I've got the new decay in the exponential form for strontium, 1 times 0.9755 to the x power. And notice when I graph these, they look identical. So it is truly a conversion. And then let's go ahead and solve that problem for how much is left after 50 years. So you're going to go to your window setup and you're going to type in 50. And then you're going to go to your table, and so y sub 1, that was my half-life formula. That gave me 0.29003, which is 29%. And y sub 2, which is my exponential form, that gives me 0.28931. And of course, I would round that off also to 29%. So you can see that even though they're not identical, they are very close. The reason they are not identical is we did a little bit of rounding here for the 0.9755 to calculate b. Okay, so that's the end of this video to show you how to use exponential to calculate half-life.